when we define a class, we put these attributes, like sometimes integer, boolean, string, whatever it is. But sometimes we might also put a class inside that one. So with as an attribute, one class can have another as an attribute. Like if we have a car class, for instance, then a car might have will have an engine, and maybe we can define an engine as a class. So in a car, an instance of an engine will be an attribute of a car class. So we can increase these things like a library or a bookstore. It's by object it's a class, but inside that we might have a book objects that will keep the. So within a class we use another classes. This is called the composition. Here is one example through this book and bookstore part. So we have this book object in which a very simple one, the title, and then the constructor. We have this getter method and the setter method for the title. And then here you see at the left, you see just a representation, book object with title, which is string also. And then in this bookstore object, now we have the bookstore name, and then we have this book object, which keeps the bestseller object. So now this part is now the composition. So in one class that we defined, we are using another class that we also defined. And it can be private, public, all the other things. We treat it as just like how we treat the other attributes. And we can also give them in our constructor. That is also fine. We just say, again, in the parameter we have this, we can use this class. And then in this bookstore representation, what we see is name for the string. And then for this bestseller book, we put a book object. So in which that we again have the same book attributes and the functions, like we will have this title and the string for the bestseller book. So this is the composition part. And when we first define it, well, it will be just null if you don't initialize it. But if you use a new operator, then yes, it will have some value. I think we had seen this before, so I'll just go a little bit fast. And again, for this comparison, some of these topics are already covered, so I will move a little bit fast. Well, if we have this, just let's go over this code. We first create a book object with some title, and then we create a bookstore with some title, and the bestseller book is given like this. And then we create another book object, and then another bookstore with the same title, but now with the same bookstore, as long as based on their titles. And then when we compare this to double equal sign, will it work or not?
No.
So yeah, even though all of their values are same, they are different objects, so it will not work correctly. So we have to define this equals to function. This is again similar to what we have seen in Unit 2, so I will go a little bit fast. So for those cases, well, we can, again, for a book class, we can define a equals function or equals to function, which in this case, we can just compare their titles, so that based on that, we can say that they are equal. I think I can just go on. We have done this for a very long time, so I will. And how do we define compare two bookstores? Well, maybe we can compare their title, and then we can compare their bestseller books. So in this part, but what you have to be careful about it is we are now comparing their names. So it is a string. So we can use this equals function, and I need to give a name also. For that one, I'm still using this bookstore object, but I'm reaching to its name. And then for this bestseller object, again, this is the composition part. It's a book object actually. That's why I need to use this equals to function, and then I'm accessing that book object through this bookstore with this dot operation. So basically, we are treating those objects like we do for the how we treat the attributes. And we can also use them as an array list. So this is, I'll just go over the code. This is, again, just very intuitive, just very straightforward based on what we have seen. So we have this book object in which we have title, order, we have this constructor, we have getter and setters for the title, getter and setters for the author, and a toString function for the class. So very regular book object. Shall I proceed? Am I going too fast? And if we have this library object, in which now we can also use an array list with an object in which we put our book object that we defined, so that the name of it will be books. So it will basically keep the books in that library. And when we first create the library in the constructor, now we have to initialize our list. So that's why we put this books is equal to new array list, so that we first open the library at the in the beginning. There is no book in that, so it just implies it. And then maybe we want to add some book to our library, so we have this add book function in which it takes one parameter as a book object. And then for that one, we take this parameter and add it to our books array list. So this add book basically adds a book to our library list. And for a get book function, now we would like to search if and retrieve a book if it is in the library. So we get the book title. And then we iterate over all the books in our list. And then we check, okay, if the current book title is equal to the book title that we are looking for. If it is, we will just return that book object. Otherwise, if we couldn't find at all, then we will return null. So the object is also returning the book object that we defined. So gather function for the array list. I'm just moving on. And in our code, how we can use it? Again, in our main function, well, we first create the library. So this is now an empty library. Then we create our book objects, and then we add that book object using this add book function. We create another one, and then we add it with this add book function. We create another one, we add it with this book function. And then we can use this get book function for the title that we are looking for. We give it in this book object, and then we print its authors and the title, so we can access all the attributes that we defined for a book object and so on. So this part I think is pretty straightforward based on what we have seen so far. But do you have any question? We can proceed. Now, this part is not that much straightforward. So what is this? Inner classes. So in composition, we were not defining the class within that class. So it was defined like a book object and also bookstore object. But in inner classes means that we define an object, a class, within that class, and then use it. So what does it mean? I'll actually go and open my book object, my Java file for that. So what I will do is, let's create a car object, okay? I will zoom in. So let's try to define this class object. Let's say maybe we might want to keep the fill. How much is it? And then we can of course keep the brand or so. There might be so many, of course. How many seats? And so on. We can keep on that, but for that one, maybe we can also say, maybe we have some engine. We would like to use it in our car or in other models. Okay, so that might be maybe a generic engine. So that's why I will also create one engine here, okay? An engine class. Let's say that because maybe it has its own attributes. Like an engine might be, I don't know, cylinders, number of cylinders and so on. There's power, maybe float. That sounds more reasonable. And I would like to put one thing, which is start, for instance, as a function. So it's going to have also a function to start the engine or running the engine, whatever it is. Okay. It's content is not important for me. So, but what I'm trying to say is that then in our car, now I'd like to put this engine here because it needs to be an engine and so on, definitely. now let's say that, now I'm imagining that, okay, this engine maybe is some kind of a smart one. Based on the fuel it has, okay, it will change the way it works. Maybe it will run, if you have less fuel, it will run more economically, or so, maybe this kind of some feature in that. So I knew, but this is a feature of my engine. So I need to put it here, okay? And then I need to say, I mean, somehow, I need the information of fuel of the car that I'm running, okay? So then, how will I do that? So this is the problem, because this doesn't take, well, of course I can put it here as a parameter. This is one way, but I need to access to the feel of the car. This is one part. So what I could, this is our first motivation. It can be, we can find some other solutions, but this is one solution. I need to access to the feel of the car, or maybe some other sites. And this might be will be much more complicated in a car system. It's so complicated. An engine might need to maybe access to the AC, or maybe AC needs to access to this. Maybe we have some computer car computer, it needs to access to many things that doesn't belong to the car, that doesn't belong to that specific component, but that belongs to the car. And also this brings us that, okay, if I have this kind of an engine that is very specifically designed for my car, which probably will not work in any other car, in other car objects. Like this car only works in Toyota in this model, and so on, okay? So I cannot put it and take it and put it in a Mercedes. Okay, this should be only in that model. But if I define it in this way, okay, what will happen is, what I might do is, well, I can, in my main function, now I'm going to my main function here, then I can create a car class, okay, and maybe it's, what was it, brand? Oh, I said band? Oh, that's bad. Brand. No, I meant this. Brand is maybe Mercedes. Okay. And I can also have another car, let's say C2, and it can be Toyota. Then I can have an engine that I defined already there. Whatever their parameters are. But then I can put the same engine. So I can set the engine of this. Oh, it's E. It's also E. Okay, that's not a good naming. So I'll change it to engine also. To this one. And I can also do it for the other one. So this one, this can be also this. So they can share the same car. Like, my software allows that, okay? So that's also sounds not very suitable with the real life. In real life, this shouldn't be also the case. So as a solution, what I will do is, okay, maybe this shouldn't be like a normal composition that we can just put engine there. Instead, what I will do is, now I will take this class definition, this whole class definition, okay? And I'm going back to my car class, and then put it here. And now Java allows that, and this is called now inner class. This is the inner class. An inner class is a class that we define inside of a class. So from a Java perspective, it doesn't have any problem. You can do that. Actually, Java is pretty flexible in that. You can define. Now, this part is not following my story, but just to show what you can do, okay? Even within engine class, I can define another class. in that one I can define another class. So theoretically, it is possible, like as long as it fits in your needs, you can do that. Even within a method, you can define a class. That's also even possible. Like as long as it needs your requirements, that's also possible. But let's now skip that because it doesn't fit our story. But now what will happen is, well, what will happen? Why should I do this? Like, why did I put an engine definition within a car class? Then it means that, well, two things. First, it satisfies our condition, the second condition, actually, motivation. Now, this engine is actually belongs to the car class that I create, okay? So you cannot run it probably for a plane or for a helicopter. That's for this car classes, okay? We will use this. So it fits more to real life. And also, there's one also very good example for that is a class definition. Now, I'll put it here at the top just to make it more readable. I have this field. Let's say that, okay, to implement my run function, because it's a smart engine, it checks the fuel level, and then based on it, adapts its power. I need to check the fuel car, and if it is inside in a class, I can change that. I can change it. I can change its value, or I can just, if I would like to use it, I can just use it in it. So the class that is defined inside a class, it has full access to the attributes of the other class. So now it will make my implementation actually very easy. Like, because now I know that the engine has access to all attributes of the car class. So I don't have this access limitation anymore. Like if my engine needs to access AC, it can. If my engine, I don't know, needs to access radio, whatever, for some reason, I don't know, it can. So whatever based on, so it can access to all attributes of that class. So this is also why we might need to do that. And when we start, like this is one main motivation for this inner classes, but you'll see that also when we start graphical user interface, we will use inner classes a lot. Why is that? Well, because by definition, actually, this UIs needs many inner classes. Like I designed a web page, let's say, or a UI class, and then there's one panel. Let's say that it's a game. Okay, it shows my, I don't know, the status of my character, maybe life or the weapon that I'm carrying, or so on and so. Okay, I need to design that part. But that panel is so specific to my game. It will not be generated in another place, and it is so specific. It is so sophisticated that I cannot make it a string. I need to create an instance for it. And maybe there's also this map screen or so on. So for each of them, actually, I need to define a class, and actually this is those classes are very specific to my game panel, my main window. So when we move to graphical user interface, you will see that, okay, we will use lots of inner classes in that one, because it will be, we will need that for that one. We don't want to create separate Java files for each of these specific cases. But anyhow, we will see that motivation as the last topic of this semester. Do you have any questions so far?
What is the bigger advantage? Because if I define a class within a class, I can also do the same if it's a class, a different class, in the same package as protected or private, and use setters and getters.
If I do this as a separate class, like this that we did here, I will not have direct access to attributes of the car. I can.
Even with getters?
I can do it with the getters if, yeah. I mean, but not in that way, because if I need it, I need a car instance in that.
Yes.
So maybe I can put it as a parameter to run its functions, but the thing is that engine will not be a component of my car. So this is the main part. All right. So now let's go back to, after this demonstration, let's go back to our slides. Let me check if I miss anything here. I said this part. How can we initialize an inner class outside the outer class? So in my car object, I can create this engine with, like, I can treat it as a normal object. But how can I create this engine object in a different class, like in this in a different class? How can I do it? Well, in that one, here is our syntax. I first need to create the outer class. In our example, it is car. And then through that car class, we can only create this inner class. This is written as a static one. So there's one detail about it. So if you go back to this, in order to create an engine of a Toyota, let's say, I first need to create the car, first produce the car itself. Then, using that car instance, okay, I'm saying car.engine, okay. So here is an interesting syntax for it. So I first need to create an instance of it, and then through that instance, look at this one, C is my car instance. C.new, I'm creating an engine through my instance only, and in that one it is, and the name of the title is car.engine. It means like this engine class actually belongs to my car classes. Okay, so this is one way to do it. The example that we see here is actually if the inner class is static. So let me also show it. But actually it was in the following slides, but we can also make these classes static. That's also possible. We will see in more detail about what does it mean to make it static or not. But if we make it static, then the way that we define will change. We can basically say it in this way. With one line. If it is static, then we can create it also here. All right. I would like to stop for 1 minute for the attendance, then we will proceed. So please log in your Blackboard. There are some more examples. So here is, again, we have some outer class that is defined at the top. Inside that we have this one attribute which is x10, and then we define a class within that inner class, and it has its own attribute which is y. It's equal to also 5. And then in another class, main class, in its main function. So what we are doing is basically we first create the outer class, then we create the inner class by using this outer class. So we have this myOuter object, myOuter instance. So again, its type is outer class dot inner class. The name of our instance, and myOuter is the instance for the outer class. Dot new, and then inner class is again our function name. And then how can I access to this x and y values like how we do with the other attributes? So then we can use it. If I say myInner.y, it will give me 5, and myOuter.x will give me 10. But again, this class definition is quite different. And well, we can also define these classes public, private, whatever we would like to have as a modifier. So we can change this inner class to private. Then Now what will happen is we will actually ban it. We will not be able to proceed. We will not be able to access it since it's a private one. So it will not be reachable from this from another class. So we can also change its access modifier. And the other one is this again, this static one. So we can also make them static. So when we do make them static, the way that we create their instance also changes. And also, if we make an object an inner class static, then it will not have access to its non-static variables. So what does it mean? Let me show that through this our example. Let me zoom out, sorry, and go to this car class. So if we have this class engine that is not static, okay, and then in that one I can access to this field. You can follow it from here. So I can access the field, and it is not static, and field is also not static. But if I make this, so we'll try all the combinations. If I make static field, I can still access it here. There is no problem with that. But then I'll change the other way. So I will make this not static, but I will change my object static. So this inner class will be static. Now you see that I'm getting this error here. So basically the rule is that if it is a static class, you cannot access to non-static attributes of the other class. But if you change this to also static, then you can access. So in short, if your inner class is static, then you can only access the static attributes of the other class, but not the non-static ones.